So I guess I can start this time, unless more people come in. Welcome to my talk about OpenRazor. I'm going to talk about the past, the present, and the future. A wonderful title. Quickly, like who I am. My name is Luca Weiss. I do maintain OpenRazor, the project. I am also involved with the Postmark project. And like my day job is at Fairphone, where I work on the different smartphone standard software. So what is OpenRazor? It's a collection of software that's enabling the control of Razor devices on Linux, in short. This includes mouse docks, in general, like the keyboards, laptops, mice, mouse mats, headsets, Mac holders, so like so many different categories, also like weird Thunderbolt docks and screens, so like all the different weird devices that Razor produces or with other companies in collaboration. With over 175 devices supported, so there's really a giant number. And Razor is also pumping out devices non-stop, so like we always get new issues for new devices, so like it's probably never going to be complete. What you can control with it is just the functionality basically that Razor Synapse and Windows can also control. It's like in general like the RGB on the device, so like changing brightness, changing color. But also some other functionality that is available on some devices, so polling rate, DPI, different zones and different effects for the lightning, and yeah. Amazing. Had a short demonstration. I forgot to enable Wi-Fi. Hey, it's loading, wonderful. So you can see our wonderful ripple effect. It's like in the complete dark, so like one video I found. So basically when you press the key, it's like the effect where it goes outwards from the key and makes everything look fancy. Like on the right side you can see the wonderful mousepad that's having like the wave effect on, so make everything colorful in your life with it. It's like how does the software work? Like we do have a kernel driver, which I will go into a bit later. It's not strictly necessary, but it's basically how the project was started, and like it's difficult to change this. There's like an out-of-tree driver that's built with DKMS support. Then we have the daemon, which is basically the interface between the kernel driver and anything in user space. So it talks via with the kernel, with the sysfs files that it creates. The daemon runs on the debug session bus, so basically anything that's in as a user process can talk with the daemon easily. We also have a Python library that's basically just a nice abstraction for Python, so like very Pythonic, and you can do the different things there. We do have a few applications on the screen. It's like Razorsheen. It's my application. It's written in C++, and it's like it talks directly with the daemon via dbus, not via the Python library because it's not Python. But we do have a few tools that is using the Python library. And like when we go to the lower level, like the kernel driver is talking with the devices, so the actual communication happens via USB HID feature reports. It's like and these packets there are like 90 bytes packets that just contain like a status field, command and like a command ID and command class, transaction ID, and like basically we send this to the device and we get it back with either the parameters filled and like the status updated basically. Let's continue. Is this yeah. So a bit of the history. So the project was started in 2015 by Tim Tader with the name Razor Chroma drivers. Then 2016, Terry Kane, which was the maintainer before me basically. He joined and did a lot of improvements, including rewriting the daemon, so the user space part from C, I believe, to Python. In 2017 already, which feels to me like yesterday, we renamed the project to OpenRazor to make it a bit more, because like on some news sites before it was kind of called the Terry Kane's Razor drivers, which was always very funny to us because he didn't really see this like his project. But yeah, and then kind of at the same time I took over maintenance. As you can also see on this wonderful GitHub graph, like it's been fairly consistent. Of course, like in 2015, 2016, 2017, there was more development because the project was quite new and there was actually a lot of feature development. Nowadays, it's mostly just like new device support and like general cleanup. So we keep it working basically for new devices. And at the very beginning, it was also just the Razer Black Widow Chroma was supported, so like one of the keyboards. Like since then, as you saw in the previous slides, it expanded to very many devices. Like we also have it separated to like 5 different classes, like with the keyboards, keyboard devices, basically the mouse devices, accessory devices, and a special one for some older headsets because they're a bit special. And I think one more, or maybe not. Yeah. So what do we have currently? We do have quite a lot of things going on. So we get regular issue reports for mostly new devices, but also like just support for existing devices. So from this we can actually see it's getting used. Our GitHub repository has about 3,000 stars, which is very nice to see, even though it doesn't really mean much. Yeah, lots of pull requests we get mostly with new devices that are getting supported. Like we have over 150 different authors in the Git history, which I think for open source projects is relatively unusual. But yeah, most contributors basically add support for their device and then disappear again because it works then for them, which is good. We also have several frontends. So like in the diagram slide before, you saw that Razer Shiny, which is mine, written in C++ and Qt. Then we have the wonderful polychromatic one, which is made by Luke Howell. It looks really nice. He's really putting a lot of effort into it, and it's like definitely the best one that we have. We also have a Java-based one called Snake. It's made by Brett Smith, and we also have some other tools, including Razer CLI. We have a script that's so-called an extreme feedback, they call it. So it's a tool that monitors the CI pipeline, and when it fails, it lights up all your devices in red or something like this. It's very configurable. It was created many years ago, and it's still maintained, so it's quite cool. I think it's called Chroma Feedback. Yeah, and like what I mostly do nowadays is handling the issue reports that we get in, reviewing all the pull requests that we get. Not often do I do like new device implementation on my own, because in many cases it's not really feasible to do this yourself if you don't have the device, because the devices are all kind of special. Like if you don't send the exact correct way, if you don't talk the right way to them, they don't talk to you back. If you talk to them on the wrong interface, which in theory there should be some way of not having to hardcode this, basically three different possibilities, but yeah, so it is. And so but if you have a device, it's relatively easy to add support for yourself if you can just test it and verify it actually works. We do have a lot of Linux distributions supported, including, of course, Ubuntu and all the derivatives, but also like Arch-based, Alpine Linux, Gentoo, NixOS, Solus, Slackware, and Void Linux. So basically anything that people are using. It should be fairly trivial to support any other distribution. I mean, it's just the daemon is in Python. The kernel module is like with DKMS and C, which is a bit less nice. We do actually have support for Fedora, no, not Rawhide, the one that's with like containers and read-only stuff.
Silverblue?
Yeah, this one, Silverblue. We do have a pull request open for this, but if anybody knows much about Silverblue and like how to package stuff there, you can help me out there. The pull request has been open for quite a bit, and I haven't really had the time to review it yet. But yeah, in general, it's quite easy to support. So a bit about like what we have planned for the future. I mean, like in one sentence, like we are just continuing as we have. So we just support, make sure that new devices are getting supported. But also some in a more, let's say, backend. So we are planning to add more tests to make sure that we're not regressing any functionality, which is important because, I mean, as I said before, like it's very difficult to figure out why a device doesn't work if you don't have it in front of yourself, because you just cannot just throw packets at it and see when it does respond and do the things that you want to do. This includes like kind of integration tests with the kernel driver. So far we do have a so-called fake driver, which is kind of emulating the SysFS structure of the kernel driver, and so we can point the daemon at this structure instead, and then we can, at least from the daemon side, we basically have like all the devices that we want listed, and we can interact with them, and like it just, instead of writing to the actual SysFS files, it's writing to basically just a plain text file, which is super useful for like any development, because we basically don't have to have the device with us. If we kind of know or hope to know that the kernel driver is actually working, we can make sure at least the UIs work correctly with that. Yeah, as I said before, the kernel driver is kind of a weird thing that we have, because for most of the functionality that we do use it is for sending these USB HRD feature reports, which we could do via the wonderful HRD raw interface in the kernel, where you can basically do the same just from user space. We do have some kernel functionality that actually needs to be in the kernel. I'm slowly trying to look into like how we can separate out these parts and make them nice, and like put them actually upstream, and then the rest we can kind of move to user space. But like also not long ago there was a thread on the kernel mailing list, like if even HRD raw should be used for like these things in user space, or if it's just like for debugging. Like even the kernel people are not really sure what to do there. But in general, like the functionality that Razer devices support is not really implementable in like the existing kernel interfaces. So the most we could do is like add a multicolor RGB LED in the kernel. But like when you then start with like the DPI and the polling rate and even all the hardware effects that it supports, it just gets super messy because there's basically no kernel interface for this. Yes, I do have like years ago I started a rewrite that I wonderfully called Razer_test, which was basically doing this exact thing. So from user space, just talking via HRD raw, using actually HRD API, which is a wonderful cross-platform project for basically sending USB HRD stuff on the multi-platform. And this project actually even ran on also on the different BSDs that I tested. I think I tested on Haiku, but I think I had a problem there because the USB stack was a bit weird. But it also worked on macOS, on Windows. So in theory, we could make it more or less easily quite cross-platform, at least without the actual kernel things that need to be done. So for enabling some extra buttons on the devices and so on. Yeah, so like for this kernel driver testing that which I didn't really go into, we do have a guy made a script that kind of emulates the USB device, so the kernel driver can actually talk with the USB device, and then we can have a script basically dump the packets that our kernel driver sends to a USB device to a file. And this way we can hopefully add some integration tests so we can more easily refactor the driver so we can make it a bit nicer, while ensuring that we're still sending the same data to the device in the end. But yeah, in general the plan is continue as we have so far. Yeah, and I mean OpenRazer is not really alone. Like we do have some projects that are actually using OpenRazer or like are somewhat affiliated, not affiliated, yeah, that are in the same space and quite useful. So there are some projects for macOS that are called Razer macOS and Fruity Razer. I think there's also some others, but I'm not hearing much of them, which are basically taking the OpenRazer code and making it work on macOS. Because like historically, Razer with their Synapse 2 software has supported Windows and macOS. But with the Synapse 3 software that was slowly started to roll out, like probably also like 5 years ago, like for 3 years probably labeled as beta while requiring new devices to use it, but whatever. But yeah, with the new software they don't support Razer, macOS anymore. So these projects kind of jumped in and added support for macOS using kind of our code base as a base. There's also OpenRGB, which is a cross-manufacturer lightning controller software, and this also uses OpenRazer in the background. but it also this project also supports a bunch of other manufacturers like Logitech and like really a lot of different manufacturers. The input remapper tool is super nice because this is kind of what Razer Synapse on Windows can also do. So where you can kind of say, hey, I want the control button to be something else, and maybe put a macro on this one. So every time you press it, it actually makes a macro, or you want some other buttons just on a different place, or have extra functionality. We do have some very limited support in OpenRazer itself for this, which was added years ago. But kind of, at least my stance has always been, this is not a Razer-specific thing, and like we don't really want to have non-Razer-specific things in OpenRazer because this would kind of feature creep our project. But yeah, fortunately, the input remapper project was started a few years ago by Toby, and this is super nice, and it seems to work really well for all the people that use it. So I'm really happy this exists. You can also use this on basically any input device basically that you have on Linux. So like any keyboard, any gamepad, you can use this tool and remap things and put macros on it. Yeah, so like how you can help if you want to. Of course, if you do have a Razer device at home, you can add support for it. It is relatively simple. We do also now have a wonderful document called development.md. In our repository, which kind of goes a bit more into like how you can, how you can add support and test it on your machine. So basically, having some commands in there that were kind of just institutional knowledge before, now they're documented there. But in general, it's not difficult. You're kind of just copying previous device support. So in the kernel driver, adding a bunch of case lines to switch statements. And a daemon basically, also mostly copying a similar device and maybe adjusting it a bit to like whatever. So like changing the DPI value from like 26,000 to 30,000 because apparently you need 30,000 DPI on new devices. If you can tell other people that have Razer devices and are using Linux, apparently there are some people that don't know about this project even though they don't, even though they are using Razer devices on Linux. I mean, it would be cool if you could tell them. Of course, you can also contribute other improvements. So even some cleanups would be nice. But like for this, I'm really trying not to break anything because whenever we break something, we have to fix it again, and fixing it is very difficult. Thank you for listening. I think if you have any questions, this wonderful thing is the microphone for that.
So do you have any collaboration, like either positive or negative, with Razer itself?
There was some contact with some people at Razer years ago, and like the previous maintainer, Terry Kane, he also got some devices from him, including the wonderful Razer Chroma mug holder, which is literally a mug holder with RGB. But there hasn't really been anything in the last couple of years. Like we haven't heard of them. We also haven't really reached out to them actively. Because like even back then, like communication was sometimes a bit slow and not really much came out of it. But yeah, we like Terry Kane did get some protocol documentation for it, which also was not too helpful because I mean we figured out most of it already on our own.
And also, what's the UI toolkit used for polychromatic, I think?
Polychromatic, it was a Python, so definitely written in Python. It was using a WebKit, I think, backend in the like before, but in the last 1 or 2 years, like the author rewrote it in PyQt, so now it's using basically Qt 5.
Okay. Thank you.
Yeah, maybe you can just pass the microphone along. Thank you.
Are you afraid of? Oh, is it on? Okay, maybe it is. Are you afraid of using the word Razer in the project name? Because someday some lawyer is going to wake up and say, like, oh, slam.
So far, no. We can talk later.
And a separate question, like out of the breadth and of all the devices that Razer has, how many like roughly are supported? Like, is it like half or 99%? Or what's the how do you feel about
I
it?
think more than half. So of course we really only know about devices where people submit issues. I do have a spreadsheet with all the like as much information that I can gather about the device. So including like so all the devices are also like identified by the USB PID, so the product ID. And like for this, we have a lot. Some we don't like. We active or like we know that there's basically no functionality like RGB wise to support. But I would say like 70% maybe, or something in this range. I can give you the numbers later. I have the spreadsheet.
That's mine.
Thank you. You mentioned that you'd been trying an approach which was less dependent on the Linux kernel, and you mentioned it worked on Windows. Do you ever have anybody come into the project or the repository that is a Windows user asking for it?
No, I mean there was some years ago where somebody actually, actually also someone built OpenRaiser code for Windows using some driver thing. I don't recall how it was called. But yeah, somebody built it for Windows years ago. They haven't come back since. We have never really been interested in supporting Windows because like on Windows you can get Razer Synapse. Like the base functionality, of course, like Razer Synapse has like I think mandated login, so you need to log in to use anything.
Yeah, so
OpenRaiser doesn't have any cloud connectivity.
that was going to be my point. So like even
Yeah.
on Windows, like
Yeah.
having to have a network connection and
Yeah.
a Synapse account just to change some LEDs.
Yeah, I think so far like it has also been kind of I mean we don't compete with Razer Synapse at all basically, so we're not taking any users away from them
Yeah.
because all the users we support are on Linux and OS that can't use Razer Synapse. So you can make it work with either there's this wonderful Razer_test project. It works. Even though I never integrated it into like the Windows daemon manager, basically it's a systemctl for Windows. It's also using dbus, which is not really a Windows thingy. I mean, I got it to work. I got my UI to show it. So I mean, you can make it work somehow. I didn't spend too much time trying to getting it to work a bit more integrated. But
Thank you.
So I was wondering about the Mac OS Razer version. Do they actually contribute code back?
no.
Ah,
So
sad.
the most honestly I know about the Razer the Mac OS project is that I get people in my issue tracker asking for support for a device and then kind of indirectly implying that they're using Mac OS, and this is quite annoying because like I don't support Mac OS at all with this project. Like if they want to use Mac OS, go to these two projects. They are happy to support you, probably. But yeah, from what I can tell, like when it is, I think we got 1 or 2 pull requests so far that were actually I think tested on Mac OS, more or less. But like from what I could tell, like at least the code looked like it should also run on Linux.
right.
But I think, or maybe they use a Windows virtual machine or some Linux virtual machine to actually test it. But then, because the macOS projects, from what I could tell, like if someone goes to them to request support for a new device, they actually kind of say, hey, OpenRaiser needs to add it first because then they can integrate the code into their code base.
Fair.
So, but no, we didn't get any direct code contributions apart from like maybe like 2 people adding their device support, probably via Linux. One more question in the back.
I'll just hop on. Do you have a way for users to submit success reports, not just when things don't work, so you can really collect info on hardware that does work?
Yeah, so the question was if we get any success reports, not just issue reports, basically. No, we don't. I had the idea already quite a few years ago to add some kind of analytic thing to it, so we at least know like hey, this device is really used a lot and not supported yet, or this basically where people have OpenRaiser installed but the device isn't supported yet, or like the other way around, like hey, this device is really really well liked, and like this other device is like has maybe one user. No, currently we don't have any numbers. I mean, the for like installation numbers, the most thing you can get, like I looked at there's the Arch Linux package stats thing where they kind of very optionally collect basically which packages you have installed. And I think OpenRazor was there somewhere in the 1% range of like people that have submitted the data there. I don't know if any other distros have like open stats of like which packages are getting installed, but
That'll be the popularity contest.
yeah,
That's gone? Well, used to be one.
oh yeah.
You could make a snap if you could, I don't know.
Yeah, we also had this question a lot. I know if I still have any time until the next speaker kicks me out. We have people coming in claiming Snap is the solution to all our problems because we do have quite a few setup things that need to be done. So because the user space daemon, which runs as the user that's currently logged in, needs to talk to the sysfs files from the kernel driver, which we are using the group plugdev, which is an Ubuntu thing. But we also use in all other distros to basically give the current user, they are also part of the plugdev group, and so they can read and write to the sysfs files in the kernel, to not just make them basically chmod 777. But yeah, no, snaps are not the solution to our problem, unfortunately, because yeah, DKMS needs kernel headers to build. I was told maybe it could be a classic snap. Yes, I know that my own GUI, Razor Genie, can get as a Flatpak. I mean, it shouldn't be any problem to make it as a snap. But like even there, like I have some special code in there to kind of tell, hey, you also need to actually set up OpenRazor on the host system and not via, because yeah, if you do Flatpak install Razor Genie, then you only get the UI and not down below bits. Yeah. If it would be a user space only thing, yes, it would be. It would basically be no problem to snap this, or Flatpak it, I guess. No, not really Flatpak. Doesn't do daemons. Anything else? Any other question?
The kernel part will go away?
If the kernel part goes away, I'm hoping it will. Like with this this like integration test for the kernel driver, I'm hoping to start like refactoring a bit in the kernel, in our existing kernel driver, and then slowly start moving things somewhere else, kind of. Maybe the quicker solution would be, I mean, even like after the refactoring, would be to actually just take our C code, basically change out the code that sends the packets to the device that's currently using kernel stuff. So basically what the macOS project is doing, because I mean they don't do a kernel extension with this. They just put it in user space, make it talk to the HID device. And we could probably also do this without much risk of breakage. So this is something I could look into probably. But yeah, also years ago there was an effort started to put basically re-implement the bits that are now in the kernel driver into the daemon itself. But yeah, it just has stalled because yeah, basically there was just like 2 devices added, and like we have 175. I mean, back then we only probably had like 100 devices, but still it's just unfeasible to make sure that nothing breaks. Kind of. That's that's always my answer. Have to make sure nothing breaks. Okay. Sure. Thank you.